In section 5.3, we got into some basic factoring, like factoring by the GCF and factoring by grouping, and then a little bit of solving polynomial equations. Now, in 5.4 to 5.6, we have some more complex methods of factoring. All right? And that's really all that's in these sections, 5.4 to 5.6. It's really just factoring, and then 5.7 is then solving more equations by using those methods of factoring that you just finished, all right, in the previous sections. So this document here will just basically deal with the factoring, not the equations. All right. So the first method that's dealt with in 5.4 is trinomials of the form x squared plus bx plus c. All right. And these are fairly simple to factor, because all you really have to do is when you have the trinomial in this form, x squared plus bx plus c, you're always just searching for two numbers that have to multiply to c and then also at the same time add to b. All right? And if those two numbers don't exist, then that means that the polynomial cannot be factored. All right? That it's prime and can't be factored. But if they do exist, then what happens is you just end up getting two binomials of the form x plus p times x plus q, where p and q are the two numbers that you just found, right, that multiplied to c and added to b. All right? And of course, p and q could be negative, so those signs there between the x and the p and the x and the q, they could be negative signs, right, because the number could be negative. All right? So these are pretty straightforward, so we'll do these first examples here with this. Now, the first one is x squared minus 6x minus 7, all right? So what you're doing here, what you're asking yourself, step one, is you're looking for two numbers that are going to multiply to negative 7, and then at the same time, they're going to add up to negative 6, right? Because c is negative 7 and b is negative 6. So they multiply to negative 7 and add to negative 6. Well, what are they? Right? There's only one pair of numbers that will work with this, and that would be negative 7 and positive 1. Right? So that's kind of what you're thinking. You're just thinking this. And now you're basically done, right? Once you have those two numbers with x squared plus bx plus c trinomials, you just put them into two binomials of the form x plus the first number, so x plus negative 7 is just x minus 7, times x plus the second number, and the second number is 1, so x plus 1. And that would be it. X minus 7 times x plus 1. And then, of course, you can multiply that out to just check it. Right? You would use FOIL there to multiply that out and check it. And it would work. I'm not going to do checks. And then the second one, x squared minus 8x plus 12, you're looking for numbers that multiply to 12 and also add to negative 8. Right? This one's a little bit different because being that they multiply to a positive but add to a negative, it means they both have to be negative values. So what two negative numbers multiply to 12 and add to negative 8? Well, that would be negative 6 and negative 2. Now, just realize that what I'm writing here, you don't really have to do this when you're solving these problems. I'm just kind of showing you that that's kind of like the thought process that you would go through. Right? So you found the two numbers, and once you find the two numbers, again, they go directly into the binomial of the form x plus the first one, which is x minus 6, times x plus the second one, which is x minus 2. And that would be it. So it's just x minus 6 times x minus 2. All right? And then we have a couple more of these. Well, 3 more actually to be exact. All right? And it's the same process. So in the third one, what two numbers will multiply to negative 20, but also add to 8. All right, well, negative 5 and positive 4, no, but negative 10 and positive 2, oh, no, that adds to a negative 8. I need a positive 8, so I have the wrong signs. So this actually should have been positive 10 and negative 2. Right? 10 times negative 2 is negative 20. 10 plus negative 2 would be 8. So then what does this factor into? It just factors into x plus 10 times x minus 2. Right? And then 4, more of the same. what multiplies to 10 and adds to 7? Well, this is an easier one because this one they both have to be positive, right? They're going to multiply to a positive and add to a positive. So 10 times 1, well, that works, but it doesn't multiply. It doesn't add to 7. So the only other possibility would be 5 and 2. So 5 times 2 is 10. 5 plus 2 is 7. So this thing will factor into x plus 5 times x plus 2. Done. And then the last one, well, what multiplies to negative 4 but adds to negative 5? Well, they multiply to a negative, so it has to be a negative and a positive. So I could do a negative 4 times a positive 1, but that would add to negative 3. If I do a negative 2 times a positive 2, that actually adds to 0. So it looks like this is not possible, right? So if those two numbers don't exist, that means that this thing does not factor, so we call it a prime polynomial, right? That one is prime, meaning it can't be factored at all, right? It's just like a prime number, like 3. You can't break down 3 at all, except into 3 times 1. So 3 is a prime number. This can't be factored except as itself times 1, so that would be a prime polynomial. All right? So that's the first method of factoring, which would just be your basic x squared plus bx plus c. Our second form of factoring from these sections would be trinomials of the form ax squared plus bx plus c. Okay? And you see the difference here is you actually have a coefficient now other than 1 for the x squared term, right? The first type was x squared plus bx plus c. Here we have ax squared plus bx plus c. So there's two ways of doing this, right? You can do it by guess and check, or you can do it by what's called the AC method. And I think what I'm going to do is I'm going to do the first one just by the guess and check method, just to show you how that works, and then I'll do the second one, example 7, by the AC method. Okay? So if you're just going to do guess and check, what you do is you realize, all right, well, there's no GCF here, right? There's nothing that'll go into all 3 of these, because 2 will not go into 5 or 3, right? So you can't factor by GCF. So you immediately just say, all right, well, the only way this is going to factor is if it factors into a binomial times a binomial, okay? And what you're going to do is you're going to say, all right, well, my first terms of each binomial have to multiply to 2x squared. So I need 2 terms that are going to multiply to 2x squared. And there's only one way that you can get 2x squared that way, right? Is you have to have a 2x times an x. That's the only possible way you're going to get 2x squared, right? Is 2x times x. There's no other way to get it, okay? And then the second terms of each binomial have to be numbers that will multiply to negative 3. And this is also very easy because there's only basically 2 ways that can happen, right? You can have a positive 3 and a negative 1, or a negative 3 and a positive 1, right? So bottom line is there's really 4 options here. It's either going to be 2x plus or minus 1 times x plus or minus 3, and then 2x plus or minus 3 times x plus or minus 1. So what you kind of have to do here is you kind of have to see what's going to work by playing with the outer and inner terms. So let's just say I put a 3 here, or a negative 3 here. Now my outer term would be a negative 6x, and I need my middle term here to be a negative 5x. So if I had a negative 6x, and then I put a positive 1 here, that would make the inner term a plus 1x. So I'd have negative 6x and positive 1x, which would give me the negative 5x. Which I want, right? So what I just wrote there, that's my factored form, 2x plus 1 times x minus 3, right? And I mean, again, what was another option? Another option would have been to put a minus sign here in front of this one and a plus sign in front of that 3. But that wouldn't have worked, because then when you multiply the outer and inner terms, they would not add up to negative 5x. Right? So that's why it's guess and check. Right? It's figuring out what all the possibilities are and then seeing which one of those possibilities is going to work. Okay? So that's guess and check. Now the second one I'll actually use the AC method for. All right? So the AC method is going to tell us that we need to find two numbers that multiply to AC, right, A times C, and add to B. So that's just the first step now. So in other words, in this one here, example 7, we're going to look for numbers that will multiply to A is negative 12 and C is 4. So AC is actually going to be negative 48. And then I need numbers that are going to add up to B, which is 13. Right? So they have to multiply to negative 48 and add up to 13. So do these numbers exist? Well, positive 12 and negative 4, nope, not quite, because that would add up to 8. So the one that would actually work here would be if I used 16 and negative 3. Because 16 times negative 3 is going to be negative 48. 16 plus negative 3 is going to be 13. All right? So the big difference, and this is the difference that if you forget this, you're not going to be able to do any of these problems correctly. Right? Once you find these numbers, you're not done. That's not the end. That's now when you do the x squared plus bx plus c ones that we did previously. When you find those numbers, you're basically done. But here, you're not done. Here, all these numbers do is they tell us how to break up this middle term, right? Break up the bx term into two terms using the numbers you found in step 1. And what numbers did I find in step 1? The 16 and the negative 3. So what I'm going to do is I'm going to rewrite this thing as 4 plus 16x minus 3x minus 12x squared. Right? And again, I didn't mention this at the beginning, and I should have. This is written in reverse order. Right? This polynomial is written in reverse order. It's not written as ax squared plus bx plus c. It's actually written as c plus bx plus ax squared. Right? So it's still the same process, though. The same process works. So all I did here was rewrite 13x as 16x minus 3x. Right? So the idea of doing this is now it's broken up, and now what I do is I just factor by grouping, and it'll all work out. So remember what grouping said is, grouping said take the first two terms, a GCF from the first two terms would be 4, and then I'd be left with 1 plus 4x. And now take a GCF from the second two terms, and since they're both negative, since specifically the third one is negative, I'm going to actually take out a negative GCF, and the GCF here would actually be 3x. So when I take out a negative 3x, negative 3x divided by itself is 1, and then negative 12x squared divided by negative 3x is actually a positive 4x, right? Because that was a negative over a negative, so it became positive. And now you can see, what do I have? I have a GCF, 1 plus 4x. And this was what you do in grouping all the time, right? Once I had the 4 terms, it's just grouping. So as long as you were okay with grouping, once we broke it up into 4 terms, you should have been really okay here. Okay? So now the GCF was 1 plus 4x. And then what's left when you take out the 1 plus 4x? 4 minus 3x. So there it is. And again, multiply out to check, right? That would be your factored form. 1 plus 4x times 4 minus 3x.